May reminded me yesterday. Guys, when I did on Monday, when we checked our multiple choice answers, there was a mistake on my key for number 14, okay? And I don't know if 14 was A when we did it together. I don't know if you got it right or wrong on your multiple choice and didn't mark it right or wrong. I'm just telling you this because it could affect your score.
Yeah, I marked it the wrong reason.
And you had it right, so you were able to fix it? Okay. So I didn't say it when I was going over it, number 14. I just did it, and we moved on. And it sounds like some people caught on that my key had been wrong. I just didn't change it. Okay, so when you graded yours on Monday, it said that 14 was D, but it was A. Okay, so don't stress about it. I just want to let you know because I don't want your score to go down, but it might have gone up. And, you're self-grading, so this is, your business. I am going to, next week, record just for my own reasons, what you earned on the mock, because I just like to compare later to how you do. I won't know till July 13th or something like that. But I just like to see, I like to see the improvement from the mock to the actual one, which is what will happen, I'm sure. Okay, so we just are going to finish the multiple choice today. It's all calculator. Just like yesterday, I'm asking you all to please, when I pick up my calculator, you pick up your calculator and do things with me. And we should have a lot of time left over at the end. If there's any questions you want me to go over with you one-on-one on any of the multiple choice, of course, or you can work on something for another class or whatever. Okay, so that'll be your time. But if you need me, I'm available. Okay. All right, so starting with number 79, we have the height of the tide. I'm sorry, but I get a little like blah, blah, blah when I read these word problems because it's like I don't really care. But I know it's bad math teacher behavior of me, but blah, blah, blah. Here's a function, a window, and based on this graph, which we're about to put in our calculator, which one of these matches up with it? So, of course, given an equation, we go right into y equals, and we are going to type it. It is really important to know how to type these in our calculator. I know you know what I'm saying when I'm like, I'm pushing the cosine button and I'm opening parentheses. Like, you understand that. But really, when it comes time, and listen, I've been doing this for years and years and years. Every time I get back into Unit 3, anytime I have to teach trig again when I haven't been teaching it for a while, even I make mistakes with my parentheses and stuff, and I have to kind of like remember how to do it, especially on some that have double parentheses. So it really does help. The more you type them in, the less or fewer mistakes you'll make on the day of. Okay, so please, please, please do these with me. Typing in your calculator. Make sure you change the window every time if they give you a different x-axis, so always do that. You might have noticed someone taught me how to change the brightness on my screen, so now you guys can see better. Yay! All right, so sometimes we have to change the y-axis. We talk about that all the time. I don't normally do it until I realize I have to do it, and I just go with whatever the x-axis is and say, oh, okay, we're good. I can see everything I need to see. So just by being able to put that in my calculator correctly, I should be able to get a 50-50 chance here on this question, right? Because there is no max. We only have a min in this window. That's another reason to change your window. If you didn't, you might have a max on your screen and then you would be kind of confused. All right. So I'm going to go to calc. Remember, that's where all the good stuff is that we use on our calculators. You want to go to calc, and then it's asking for, we're going to do the minimums. That's number 3. And remember, your cursor always drops, your calculator drops the cursor right in the middle. So you sometimes have to move your cursor left or right. So it's asking for left bound, so I'm going to go somewhere to the left. And just like we talked about yesterday and every day that we do this stuff, you don't have to be super close. You just want to give it an area to find it in, and it will. Okay, so somewhere to the left, enter. Arrow over to the right, and enter. And then guess, yes. And it says, you know you're on the right place because it says whatever it is, minimum, intersection, max, whatever. The minimum is at time about 6 hours, height of 3.5, okay? So X would be your time, Y would be your height, okay? And guys, reviewing this stuff is so valuable because I know you're like over it. I get it. You are tired. All your classes, you've got testing and presentations and certifications and homeworks and all the stuff you have going on in school, not to mention what you have going on outside of school. But trust me, this is going to be so worth it, because this is a great example of a question you might have gotten wrong, because it's been 5 years since we've talked about it. But once I go over it, you're going to be like, oh yeah. And then when you see this question in 2 weeks on our test, you're going to get it right. It's worth every little point that you can get. This is free college credit, guys. So that's why I need you to be buying into this and staying with me. All right, the graph of G is shown. Which of the following intervals gives the domain of the inverse? So we need to know that symbol means inverse. And we need to know that inverse is switch X and Y. And domain and range is just X and Y. So for example, in the graph of G, the domain and the range are these. Okay, so domain is your X values. So from 2 to 8. From 2 to 8, always least to greatest. From 2 to 8, those are the X values we use. And the range would be from 3 to 9. So that's of G. So for the inverse, you just switch them. And I'm not going to write it all out. But if you want the inverse, you just switch them. So for the inverse, I'll write it. The domain would be 3, 9, and the range would be 2, 8. Right? So the domain of the inverse would be the range of the function. So that's why we would get 3, 9. If you got it wrong and you just listen to me, you're not going to get it wrong if you have to get another one of those. Because it's easy. You just have to remember that. Okay? You don't even have to have a calculator for it. Okay. All right. 81 is, so, everybody has a way of doing things, right? Like, think about just anything in life. You have your own way of doing whatever it is. Washing dishes, doing your hair, whatever, okay? Everybody has a way of doing things. I'm not excluded from that. I had a way, I've done this problem, and I hated it. I hated this problem. And in first period, this girl Chloe and another kid Yevgen, they really helped me see a different way, an easier way of doing this problem. And I was like, oh, thank you. I'm going to use your method going forward. So here's what they said. So here's what's going on in this problem. So I just wanted to give them credit. The graph of h of x is shown, and it's a log, okay? Which equation shows the inverse? So here's h of x. Which one of these is the inverse, switching x and y? And so I did this kind of complicated method. I used to hate having to go over this problem because everyone's like, well, I'm never going to remember to do all that. So they said, you know what? You always tell us to use the stuff, the answers and stuff to help us find which one is right. And they're so right. So remember what I said, with an inverse, you switch x and y? Well, here's the graph. In this graph, we have 2 points, right? We have a point called 3, 3, and we have a point called 5, natural log 3 plus 3. I'm going to actually put that in my calculator so I know what it looks like in decimal form. You know your calculator is not going to give you ln 3 plus 3. So all I'm going to do real quick is do ln 3, close my parentheses, plus 3, and just enter, and just see what that decimal is, okay? So those are 2 points on this graph, right? The inverse, and you wouldn't necessarily have to write all of this, the inverse would have, just switch it, well, 3, 3 switched is 3, 3, and it would have 4.095, right? Switch x and y. So all they did is said they came up with this right here, and then they started putting these in their calculator and looking at the table to find which one of these had these 2 ordered pairs in the table. And furthermore, and I was like, okay, that's fine. That's a great method. Love it. But we might have to do it 4 times. And then they said, smart kids, they listened to me. Well, they started with B and C because they're so similar that they felt like that's what test makers do sometimes, is they put 2 that are super similar in there, and they were right. So I'm going to put in B first. I need to clear my RAM. You're going to clear your RAM between every problem. Don't forget to do that, guys. That's really important. And I'm going to just start by putting in B, okay? So I'm just going to type that in. Where is the E to the power button? It's always going to be hanging out with natural log, because natural log and E go together, so it makes sense that it's on that, above that. Okay, so I'm going to put in E to the x plus 3, an arrow over, minus 2, okay? And I graph it. Actually, I didn't even need to graph it, so you don't have to waste time. You can go straight to the table, which is all we really care about. Well, if you look, 3, 401, clearly B is not the answer. Okay, I didn't even have to worry about this point. I need a 3, 3. Okay, then I can worry about this point. So let's try C. So I'm going to clear that out. So again, second natural log, x minus 3 plus 2. Again, I don't need to graph it. I can go right to the table. Ooh, there's 3, 3. Now, how do I see if they have 4.095? Oh, I didn't even think about that. Maybe. Let me see. I don't know if that would work. Let me see. 4 point. It's really close. Okay, so let me just tell you, and I like that. If you didn't remember the actual way I was going to tell you to do it, that would be a good way. I like that you guys thought of that. They went to table set and said change the table to start to 4.09. Don't forget we rounded it. It wasn't really 4.09. It was some really big number. So when I go to the table now, 4.09 gives me really close to 5. I would feel pretty I would feel pretty comfortable with that. You know, Remy, are you getting what I'm saying with that? But let me just tell you how another way. And guys, who knows what sticks in your brain on the day of? There's more than one way of doing a lot of these, so it's good to talk about all these. I'm going to go back and putting that as a 0. Okay, so what you could do is put y equals 5 as a second graph, and then do intersection, and that should give you your x value, right? So if I do second trace 5, enter, 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 I get 4.09, blah, blah, blah. So that's another way you could have done it, and that would have told you the answer was C, okay? So it seems like a lot because I had to talk a lot in that, but it's really not that bad. Guys, don't give up on a question. You saw how much time you had in the multiple choice, especially. The FRQs, I know, we are tight on time. But you have the time in the multiple choices. Think back to those of you that were there last Friday. A lot of you were sitting there at the end of the multiple choice just playing on your phones because you had so much time. So don't just guess. You know, if you're really struggling with it, flag it in Blue Book, and I'm going to teach you how to do that next week if you don't know how. And pick an answer. Always guess first and flag. Guess and flag. And that way, if you do have time, you can go back and work on it some more. But if you run out of time, at least you have a 25% chance of getting it right by guessing one. Okay? Okay. 82, we had a problem just like this in the non-calculator portion, and that was given rectangular coordinates of -2, 5. We're going to switch it to polar coordinates, r and theta. And if you remember, the very first step was to graph that point and make a triangle out of it. Guys, stay with me. And if I go left 2 up 5, I'm in quadrant 2. So left 2 up 5. And on the one we did before, we then did Pythagorean theorem to get our r. I don't need to do it on this one. Why? Why am I not going to waste time on my Pythagorean theorem? Yeah. All of the radii are the same. Why would you waste time on that? You're not getting credit for doing work, so who cares? But if they were different, you would do Pythagorean theorem. 5 squared plus -2 squared equals r squared. Find the square root. Okay, you'd get 29. All right, the other formula is what we really have to talk about. To find theta, we do y over x. Always y over x. Okay, so tan of theta equals 5 over -2. The one we did in the non-calculator section, we got a -1 here, and it made sense to us. All of our denominators of 4 have tans of 1 and -1, and we just found the one that was also in this quadrant, 3 pi over 4, and we were done. This is a calculator problem. We have to use our calculator. Don't forget, whenever you need to find an angle, you use your inverse button, also known as arctan, inverse tan or arctan. That's just the second tan. So you have to put that little -1 in there. And then 5 over -2. Now you're going to get a negative angle. Do we have negative angles in quadrant 2? No. Quadrant 1, 2, 3, and 4 are all positive angles. Why did we get a negative? Well, because your calculator is really good, but it can only give you two possibilities, a positive and a negative answer. That's all I can give you, a positive or it doesn't see the triangle. It doesn't know you want quadrant 2. It gives you a positive answer if the two numbers when you divide them are positive, or it gives you a negative number, okay? So all your calculator can do is give you this quadrant when you get a negative theta, right? This is backwards quadrant 4. Remember, negative angles are going the other way. If you get a positive answer, it gives you quadrant 1. We don't want either of them. We want quadrant 2. So all you have to do, if you have this quadrant, how far away from that quadrant are we? Pi. Right? That's pi distance. So all you have to do is add pi to that and put it, you can just do it right in your calculator, and you should get 1.951. Okay? So we had one like that in our notes or homework a while ago, a few weeks ago, but there it is again. So I'm sure a lot of people chose D, but now you know there's no negative angles. You can't have a negative angle in quadrant 2. Okay? So hopefully that triggers that memory. You get it all done, Sam? Did you grade your multiple choice yet? No. All right, number 83. Take a second, clear your RAM, start typing this in. This is one of those that I have to do a couple of times when I'm getting back into trig to remember how to put it in the calculator. Make sure you cleared your RAM. Everybody should be putting this in their calculator. Please, please, please. Don't make me do this by myself. I know how to do it. Okay. And then I'll read the problem finally. There's some complicated parentheses in this problem. You want to know how to put it in your calculator now so you don't get stuck on the AP exam. You know what they're asking, but you can't figure out how to type the darn thing in, okay? So you have to know. And if once we're done, if you're still having trouble, I will come help you one-on-one after we're done with everything. So just remember that you need to ask me about this problem if you get stuck. Okay? So what is this asking? Alien from blah, blah, blah for real on this one. The alien's body temperature is represented by the function, and which one of those, A, B, C, D, best represents what's happening to the heart rate at t equals 60 minutes. Okay? So before I graph this, I'm going to for sure want to change my window. Okay? So when I go to my window and I do 0 to 120, if you hit graph right now, nothing's going to happen, and that's normal. Okay? Because let me remind you of something. This is the type of problem I definitely would know ahead of time, and you will too after I remind you of this. You'll know ahead of time that you have to change your y-axis because remember, this is your midline, and this is your amplitude. So of a cosine graph, remember we normally see the 115 at the back, but sometimes we see it at the front. So that's 115 plus 9. It's going up at least 124. So I'm going to change my y max to maybe like 150. You guys know that's negotiable, what number you put in there. Okay? And then graph it. Okay, great. It's a cosine graph. How do I know what's happening at t equals 60 minutes? Where the heck is t equals 60 minutes? Fine, I could look at my table. It's really just going to give me some numbers and everything. I want to know, are we increasing or decreasing there? And the rate, when we talk about increasing or decreasing rate, what does that have to do with? What word? One single word. Concavity may, yes. So we want to know if it's concave up, concave down, rising or falling. So there's a couple different things you can do. There's a feature on your calculator that I've only talked about very briefly that would be perfect right here. Look, go to your calculator. That's where all the money is, right? That's where everything that we do to a graph is. Min, max, intersect, zero. It's value. You know what value does for you? If you hit value, look, it gives you an x equals at the bottom. You can put any x value you want in, and it'll drop the cursor right there on that spot. Okay, so we can do 60, right? T is time, that's your x-axis. So that's 60, and hit enter, and it puts a point right there. That's t equals 60. And that's, if you went to the table, that's the ordered pair you'd see. Like I said, the Y value is not really helping me here. Can you tell what's happening there? Maybe you can. I can tell. I'm going to tell you what I see, but I'm going to tell you another thing you could do if you can't see it. I feel like it's increasing, right? It's on a section of the graph that's rising. And do you guys think that that's concave up or concave down there? Down. It's on a section of the graph that's concave down. And that might be hard for some of us to see, so I'm going to show you something else. But if you're good at that part, you would say, okay, increasing, so that's rising, and concave down is what that means. So with that, a couple different things you could do. You could shorten up your x-axis. This is one, well, let me do something else first. If you put your midline in as a different graph, 115, it makes it, and then I go back to, you have to do this again, what was it, 60? It kind of gives you a reference point where you can kind of see, okay, that's definitely on an increasing section and it's concave down there. That might help you. Or you could go to your window and make it a little smaller. Like do, I don't know, you could play with it, 20 to 100. Let's see what that looks like. And then you could do the value again. But this is still kind of wide in my opinion. But you could just play with it like that. My best advice is to put your midline in. Thank you. Best advice is to put your midline in, and that makes it a little bit easier to see. Okay? Do we get that one? All right, 84, you don't need a calculator. Here's a function, how many points of inflection? Points of inflection are where concavity changes, mins and maxes, right? Where your concave up switches to concave down. No, that's not what I mean to say. Where increasing changes to decreasing or vice versa. I said that wrong last period, I just realized. There's a formula for it. So if you don't know the formula, which is super, super easy, you could graph it and see how many mins and maxes you have, right? But there's an easier way, because that takes a minute to type in. Fine, easy, but here's the formula. The degree minus 1. So whatever your degree is, you subtract 1, that's how many POIs you have. So if you knew that formula, awesome, easy. You don't even have to waste time typing it in. Okay? Sam, we're in the gold packet if you want to follow along with us, because I know you just jumped in with us. Okay, here's another great one. Why reviewing is so helpful. You guys, we did logarithmically scaled graphs for 5.2 seconds and never talked about them before, and you probably will never talk about them again. I've never seen them in calculus. You don't do them in algebra 2. This is something that pre-calc thought was important, but it's so easy once you remember the teeny tiny things you have to look for. And they're definitely going to give you one of these on the AP exam. I guarantee it. I would bet a year's salary, because they make such a big deal of making sure we cover it. They're going to put it in a multiple choice, okay? So let's get this point, because it's super easy. All this is saying, the table of values, which one of these is this table of values? But it also has to be a semi-log plot, which means the vertical axis is logarithmically scaled. It'll always say that. So the vertical axis is the y-axis, right? And what that means is counting by base tens. So we know the answer is C. Let me tell you why it's C and then why the other ones are not. So your y-axis, these are base tens, right? 10 to the 0 is 1, 10 to the first is 10, and so on. That is logarithmically scaled. Now, before I finish telling you about that one, this is the only other one that has a y-axis that's logarithmically scaled. 10 to the 0, 10 to the 1. So if you look at the other two, look at the y-axis, it is not base 10. So those immediately go away. Those are not log scaled. Okay? How do you choose between these two? Look at the points. Okay? For example, this point right here, right? This is 1. This would be 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this is 2. So this point right here would be 5, 2 point something. I'll make up a number. And it should be 230, okay? So one of these will be correct and one will not, okay? And this one, see, 5, this is 2, this is 100, 200, 3, 4, 5, 6, 7, 8, 9, 10, and that's why this one is the answer. So the answer was C. On my paper that's a little bit better printed, had better ink. The logarithmically scaled graphs have that weird, like, it almost looks curved. See how these two are just like normally spaced? That tells you those are not right. Okay, so these two, you can almost glance at it. What you're seeing here is like this one box. This right here. You're seeing from 1 to 10, just stretched out in B. Okay, so that's another easy one. If you just listen to what I said, you can get that point easily. Did anybody get it right? You did? Okay. Maybe you remembered, maybe you guessed. I don't know. Okay, good, good, good. 2 more, we're almost done. 86 gives us a table of values. Okay, table of values. They give it to us. How many of these have we seen? Okay. Then it says an exponential regression is used to model this data. Okay, so now I know we're going to think of this as actual. Remember, scientists do some whatever data collecting, and they hand it to us and they tell us to do some mathy stuff with it. This is the data that scientists collected and handed over to us. Okay, and we are going to do an exponential regression to model that. And then I'm going to go back to the rest of the question. So let's start there. Clearing your RAM. What button do I press? Stat. And type in your data. Everyone should be typing, not just me and the 4 people that are paying attention. 5, 3. Jaden, you got this one? Then what do I press? Stat over to what? Calc, and then you have to find exponential regression. Look for it or just know it's at 0. It's a common one we use. So you can just hit 0. We're going to store it. Alpha trace, enter, enter, enter. Do I need the equation? No. Do I need the graph? No. Actually, I haven't finished reading the question, so you don't know what we need. The residual is given. Okay, so now they're talking about residual. They start talking about residual, there's a formula we need to remember. This is one of the formulas on your formula sheet. The residual is your actual minus the predicted. And it's in alphabetical order. A minus P. Actual is what, you could think of it as what's given to you, right? What's given. And predicted is what your calculator gives you, okay? And we always use the Y values. Okay, so what is this question asking? Okay, they're giving us a residual. They're giving us a residual. So they're giving us the solution, if you will, the left-hand side of the equation. We are going to use it to find G of 5. Understand this notation. That's this right here. We want to know what 5 is. So if you have an equation, it's got 3 parts, residual, A, and P. We have residual, and guess what? We need the actual, and we can find the predicted by going to the table, right? So if I go to my table, in my table, 5 is 1.49. So what I'm going to just make a little equation. My residual equals my actual, which I don't know. You want to call it X, call it George, whatever. That's my unknown. That's what I'm trying to find, 5 of that, minus the predicted, which is 1.49. And then solve for X. So you do 0.627 plus 1.49, and your answer would be 2.117. Okay? Last clearing of your RAM. We had this question, guys, stop talking please. We had this question twice in the non-calculator portion, where you're given f of x or g of x and h of x, 2 different equations, functions, and you're asked for the points of intersection. Without a calculator, we set them equal to each other and solve for x. In the calculator, we'll use the intersection feature. So we're just going to type these both in. 2.8 plus 4.5 sine x. How do we type cosecant in. There's no button that says cosecant. 1 over sine. Cosecant's friend is sine. Remember, they're reciprocals of each other. So 1 over sine equals cosecant. So 1 divided by sine. 1. Good job, Remy. 1.75x. Okay? So you type them both in. And if I'm going to graph it, you guys change your window. You don't need to graph yours. I just wanted to remind you what cosecant looked like. Remember when we had to graph cosecant and secant, graph sine or cosine, and you made your little parabola-looking things and your asymptotes? I just wanted to remind you. But that's what it would look like if you didn't change your window. Always do change your window, though. And we want to find the points of intersection. And you will notice that there are 2 of them. You have to find both. Okay? So second calc number 5. And since my cursor is there, I'm just going to find that one first. And remember, intersection is the easier one. You don't have to have left and right bound. You can just hit enter, 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 and we get 1.716. You get that. And then second calc. Now I'm going to arrow over. And you guys, you don't have to be on the left side. This is the one that does not have to be left and right. You just have to get close to it, hit enter. It'll always jump to the other graph for you, and you just hit enter again, enter. And then we get 0.164, so it should have been A. So the calculator section, I predict you guys are going to do pretty well on, because you guys, meaning my students, seem to do very, very well with the calculator. So just little things we have to be careful of. Okay? If you are